on. Okay. Okay, I think we'll go ahead and get started. It's good to see so many SQL Server people here. It's excellent to see. My name's Cameron Gardner. I'm a Principal Program Manager in the Azure Customer Advisory team. And before that, I used to work in SQL Server engineering. I then moved to the SQL CAT team, and for quite a few years I've been in Azure CAT. Anybody in Microsoft who's worked in SQL Server, our favorite product is always SQL Server. We love this product. So I'll start right away. In Microsoft Customer and Cloud and Enterprise Group, we think companies who embrace data and who are responsive to customers, they are going to be far more competitive than those who are not. It's as simple as that. So data is at the center of the diagram up here. And it should be at the center of any modern competitive business we feel. So it should be pretty intuitive that if data is the center of your business and is important to staying competitive, it should be intuitive that you need to wrap a life cycle around it. And this is what these few slides show. The rest of my slides will be getting into some much more detailed technical lines of code, things like that. But I do want to take the time to explain this slide because it is important. Your data lifecycle begins with capturing data. Of course, that's far more than just your traditional relational data nowadays. This could be coming from documents, streams, unstructured. Every DBA out there today, I think, has to think beyond just relational data. So there's a huge middle area here, the transform and analyze. Here we have a lot of features and capabilities have gone into the SQL Server suite over the last few years. Predictive analytics is just one example. And finally, we need to visualize, and the most valuable part of the information data lifecycle occurs here with a decision. During this phase here, we'll get an insight, but it finishes with a decision. So I'll expand the diagram, and you can see the details here. Our traditional relational data here, but of course SQL Server supports a lot more than just relational data today. You can see all of the other possible sources of data. Transform, we have a lot there. There's been huge growth in this area over the last few years. The modeling, the machine learning, we're going to touch on R, we're going to touch on Polybase. The visualize and decide. So reports, our reporting services product has had a major upgrade. Dashboards and mobile, Microsoft has acquired DataZen, which is a first-class presentation tool. We're going to spend a little bit of time on that as well. Natural language query, Cortana. This is a very powerful tool. If you wanted to impress your user base, if you wanted to impress your business users, the Cortana Analytics is a really exciting product. Sorry about that. In some of the other sessions, we've covered the cloud first. SQL Server 2016 is our first version of SQL Server that we can say is built, born, and delivered cloud first. What we can do in cloud allows us to develop features and capabilities much, much faster than we ever could before. When we had to ship a product on a DVD to you as a customer, the time it took us to get feedback, those time horizons have shrunk dramatically. What can be done in days, maybe weeks, with our new development model used to take months, if not years, in the previous development model. So one area where that's particularly significant is in feedback. So the feedback we've had from customers like you for features has been incredible. We have released features into the SQL Azure database. An example here is row-level security. Row-level security is running in SQL Azure database today, and that is being ported into the SQL Box product, which will be released soon. And the capability for us to deploy that, to monitor that with telemetry, to see how it's used, to see where it breaks, to see what works, what doesn't work, that has allowed us to speed up the development of our SQL Server 2016 product. And you're going to see what we have bundled into SQL Server 2016 is pretty amazing. So the cloud-first strategy, this is a clear strategy from Satya, and I think this has let us develop a SQL Server release. You will see has more features than I think any other SQL Server release to date. So we can also be sure that our quality of our product is preserved, because when SQL Server 2016 is released to you, the features, example row-level security, that feature has been running on SQL Azure DB for months before we ever release that to you. So we will jump into the main core part of the presentation. So mission critical performance we're going to start with first. Then we're going to go through deeper insights and finish with a couple of topics on hyperscale cloud. I'll run through each of those and give you a summary. So mission critical performance, we've done so many features in here, we could fill up hours if I demoed them all. So the first one, operational analytics. How many people here have used the in-memory OLTP for SQL 2014? How many people? So a few people have used it, seen it. This was the first generation of this product. We had a necessarily quite narrow surface area on that product that's been expanded. But that did allow you to do some capabilities like what I illustrate here. So we have a highly transactional system in an OLTP database. We've moved our tables in memory. We've maybe compiled our stored procedures to native stored procedures, so they use much less CPU. But still, we're stuck with a problem. When we want to do analytics on that data, we have to do an ETL process. So we have to extract that data out of your OLTP and put it in some kind of data warehouse. So with SQL 2016, we've got capabilities and features that mean you no longer have to do this. So I will start. Can you switch to the other screen? The demo screen, okay. I'll start with a familiar demo that some of you who saw when this product was first announced for SQL 2014, you would have seen this tool here. What I've done is I've created a column store index on top of the table underlying this, but I'll show you the tool nevertheless. Now, this is an Azure VM, and Microsoft does have Azure VMs with 32 CPUs and 448 gig of RAM. But in terms of giving Azure accounts to internals like me to run those, that's another question. So I have reduced the number of threads here from 40 to 20. So when we start this off, you can see probably a familiar pattern that you might see on some of your on-premises systems, latching. So these are one of the more famous. So page latch SH is one of the latch types we'll see. I'll actually show you this DMB on sys.dm exec requests shows you the exact latch type. So that's a schema stability lock, if I'm not wrong. And here's page latch SH. Page latch SH, very different than page IO latch SH, which is an IO latch type. So this application here is causing a lot of latching on SQL Server and very high CPU consumption. You can see here 90% or thereabouts. What we'll do is stop this and change this to an in-memory table. Then I'm going to show you the change I do. Now, some of you will be able to read the T-SQL here, that I'm putting a column store index onto this. So this was not possible in SQL 2014. Now, I wanted to prove to you today that the performance benefits of moving the table into in-memory is practically identical down to the margin of error of measurement if I did not have that column store index on that in-memory OLTP table. So the overhead of my column store index here is very, very little, very, very small. You get about exactly the same number of transactions. You can see here my CPU is still quite busy and my latching has completely gone because there are no more latches anymore. There are no more pages. I've moved this to an in-memory object. Those of you who are familiar with the SQL 2014 know that we have another stage of optimization where we change this object from a normal stored procedure to a compiled stored procedure. And you can see the performance benefit here. Now, this is still running, updating the in-memory table, which has a in-memory column store index on top of it. And you can see we're about 5 times X. And this is running on an Azure DS12 VM, I think, with premium storage. So to deliver 4 to 5X is quite significant. So going back to our example here, ETL processes, they often take too long, and ETL processes often may fail. So the time until I can do my fraud detection here, 2 to 24 hours, it's too late for a lot of businesses. I'll give you one example of someone who's using this, and it's a company, it's not in Australia. They are a utility broker. So I think in Australia you can get your power and your gas and your telephone, your internet from a variety of different companies. You've got a deregulated market, I think. So this company is a company that is a broker for your utilities. You can ring them up and say, can you give me the best deal for internet, gas, water, and electricity? They have a web form as well. What they do is they use a technology to find abandonment. So there is a customer who wants to sign up, use their service, but on their form, it has a question, what is your driver's license number, for example. So the reason they want your driver's license number is they want to obviously check your credit. Now, in an audience this large, there will be some people in this auditorium today who don't drive cars and don't have a license. So sometimes those people, when they're filling out that form, they get down to driver's license and they close the form. This company, when an event like that happens, they use the SQL Server column store index to analyze that and immediately get their call center to phone the person. Because just because you don't have a driver's license doesn't mean they don't want to sell you electricity. An abandoned form, an abandoned customer is a lost opportunity. So, what we have the capability to do in SQL 2016 is merge those two objects. And that's what my demo here has done. And I will show you some of the outcome, what we can do with that. Now, I don't have very much data because we haven't been running it very fast for very long. But we can see that we have a little bit. So, for example, column store is highly effective. Oh, let's choose the right database. So column store is highly effective for operations like sum and average. What I'll do, I'll actually put on include the actual query plan here. And run this again. Now you can see here is the column store scan. Now at large data volumes, this is going to be orders of magnitude faster than even that same operation on an in-memory table, just because of the efficiencies of column store. If you have a wide table with many columns, and you're doing a sum on just one or two of them, then this is going to be way, way faster to do that on the column store because of the efficiencies of the column store. So we don't have so much data, but let's try seeing how long that takes. Okay, so noticeably slower. Here I used an index hint to force that to the primary index here. Also, the degree of parallelism that our column store architecture can use it responds very, very well to parallelism. So SQL Server 2016, now that we fully support this functionality on in-memory objects, we also support it on normal table objects too. So you can have a normal table with a column store index or a column store index with a B tree index as well. Either way round we support. Any questions on this functionality? Okay, next one. So, always encrypted. This is a request that's come from so many customers. Security is a big topic for you. So over the years that I've been involved with SQL Server, we have given you, I worked on auditing. I think that was back in 2012. We used to have only 2 behaviors for auditing. So if you configured auditing and your audit event could not be written, we had 2 behaviors. One was ignore it, and the other one was to stop the SQL Server engine. In 2012, I think, we added a 3rd behavior, and that was to fail the transaction. So that would be the preferred configuration in most cases. We've provided you transparent data encryption. We're providing you with row-level security now. We have a whole bunch of security features that we offer, including in SQL 2014, we added backup encryption. So if you use TDE to scramble a database, all of the backups are always encrypted. Now you do not need to fully implement TDE. You can say backup database with encryption and specify your encryption algorithm. So always encrypted. What is the difference with always encrypted? Even with TDE, we protect data at rest and we protect backups. By the way, backups are a very common attack vector that you would never know about if someone steals your backups. You don't know about it. Your system keeps running, but suddenly your competitors seem to have a disturbing knowledge of your pricing or whatever. They don't know that you've compromised their system. So all of the technologies until today had the problem that they could be compromised by man in the middle. So always encrypted is at the client level. So here you see our .NET. Now at RTM, for those of you who are interested, we are going to support ODBC and JDBC as well. That's not in CTP3, but it will be in the RTM product, I've been assured. So TDE, how does it work? You can see in the diagram that a customer has got here a social security number, which is an American concept. That has been replaced by ciphertext. The client has got a key which can be used to unlock that key. But all of the transmission, if you put a tool like Netmon or WebX-Ray onto the network connection and you trace the TDS stream, you will just see ciphertext. You will not see the real data. I'll give you an example. So here I'm taking the standard Adventure Works database. By the way, it's not so clearly mentioned in the slide, but it's also possible to store the keys in the Azure Key Vault, and I would recommend that you do so. And for those of you with very high security systems, if you separate the functions of the person who looks after the keys and the DBA, that's also a good idea. So I've provisioned my Key Vault here. And I'm going to copy a table from AdventureWorks into here. And this has got list price, which, let's say our pricing information is secure. We don't want that to be compromised. What I can do is come into here. I'll have to refresh. And I say encrypt columns. Now, just a couple of things. Because I'm using the Azure Key Management Solution, and because I'm a Microsoft staff, we're going to be testing Microsoft's two-factor authentication. So these live demos are always interesting. Just a couple of points here. Deterministic and randomized. Does anybody know the difference between those two? A fully randomized ciphertext, if I have repeating information, it's going to have different ciphers. So if I had data that was quite repetitive, like if this field here was region, and it was either north, south, west, or east, then I would eventually have repeated ciphertext. If I use the fully randomized one, then I will not be able to detect any pattern. It will be completely random. So we'll leave it as deterministic. So I'm going to sign in using my Microsoft account. It is going to ask me for secondary authentication. So if everything's working, I'm going to get a notification, which I just did. And there are two ways of doing this. Either it will call you, or there is an app you can download and enter in your PIN. And I just entered in my PIN, and this should authenticate me on and display the key vault that I just created a few moments ago. I think the network here is a bit slow. This is my Azure account that I use, and here's the key vault I created not so long ago. So we're going to put the keys into my key vault, so I keep them centrally managed. And then we're going to encrypt those columns. Now, obviously, for a larger table, and if you use a fully randomized key, this can take a little while, but this is just quite a small table. And I chose the deterministic key, which is less expensive. So, provided your application, most applications you can encrypt columns, and most applications will not be too aware that the underlying data has been scrambled. So this was the table before, and now after that is, I'll change to this view so you can see a bit better. You'll see this is completely scrambled. And if I use the fully randomized key, this data is completely meaningless. This also means I can protect my database against the DBAs. So the DBAs can go onto the database, select star from table. They're just going to see ciphertext. Unless they can get the keys, they cannot see anything. So this is a very powerful feature, and all of these features here are included in the SQL 2016 Enterprise Edition, included in our SQL Azure DB as well, supports always encrypted. Even in combination with some of our other tools and features, for example, StretchDB, you can encrypt a table and then stretch it. So you can push data into low-cost storage in Azure, and not only is the data encrypted at rest, but it is encrypted in transit as well. So question up the front here was, can you use this with compression as well? And the answer is yes, but if you use a fully randomized key, the ratio is very poor. So you can say alter table data compression equals page, no problem, but the compression ratio with a randomized key is very poor. Any more questions on this feature? I think this is amazing, this feature. This has so much utility for customers. Question up the front. So the question was, does the ADO.NET, or we should put on the slide as well, ODBC or JDBC at RTM, does it encrypt it when you do an insert, for example? I think that was your question. So yes, for insert, update, delete, and select. So anything going over the wire, somebody sitting there with netmon, somebody grabbing your TDS streams, that's useless to them now. So you can protect your database. Of course, this feature here, you can still use this in combination with other features like TDE as well. So you can TDE a database, but remember TDE does not protect you from man-in-the-middle, people with netmon or WebXray, and TDE does not protect you from your database administrator, because TDE is transparent. As soon as someone's opened up Query Analyzer, they can type in select star from the table. Any more questions? Another one. Question was, what is the storage consumption impact from this? I don't know, but you would typically only use this on tables that had, well, you would only use this on columns inside specific tables that had data that you really didn't want to get out. And that's usually a very small subset of your overall database. Okay, good. So, our mission critical features. So, our operational analytics, I showed you creating the in-memory column store index over and on top of an in-memory table. More in-memory OLTP, so we've expanded the surface for the in-memory OLTP as well. SQL 2014, the comment from you was it was rather narrow. We've greatly widened that. What we've also done, and it's a little bit linked over here with this, in SQL 2014, our in-memory OLTP could support 4,000 checkpoint files, and each checkpoint file is 128 megabytes. So you had 512 of use of memory, which meant you could have about a maximum table size of 256 gigabytes. Now, in 2016, we've NUMA enabled in-memory OLTP. We've got that scaling well on 4-socket servers. So remember, a 4-socket server now has how many cores? 100 threads would be 144 and can support 6 terabytes of RAM. So on powerful hardware platforms, you can run this, and you can have up to 2 terabytes. So 256 gigabytes on 2014. Now on 2016, we've tested, it scales well. 4-socket servers, up to 2 terabytes of RAM. And it's NUMA enabled as well. Query data store. I'm going to have to break away from the slides to show you this, because this is such an excellent feature. Do we have any Oracle DBAs in the audience? 1, 2, only 2. Who uses the AWR database? Yep, okay, good. So, in SQL Server, we now have a really powerful tool that will assist you. Now, I'll show you how to turn it on. I've already turned it on this machine a while ago. Very easy to turn on. Just go to Properties, Query Store, and to try to generate some data, I pushed these to pretty unrealistic intervals. You probably wouldn't do this on your systems. I would say every 5 minutes with aggregation to 15 minutes, something like that might be sensible. What does it look like? So it is super fantastic. So a lot of ISV applications have parameterized statements. So parameterized statements, as all of you know, all experienced DBAs, you'll know that if your underlying data is highly skewed, so if the majority of your sales offices are in Brisbane, Sydney, Melbourne, Adelaide, or Perth, but you've got, what's the smallest, remotest town in Australia? Or you've many of those. Kalgoorlie. So if 99.99% of the rows in your table are sales history from Brisbane, Sydney, Melbourne, Adelaide, Perth, and you just have very few that are from Kalgoorlie, experienced DBAs in the audience here will know what happens if a SQL plan, I can see a few people nodding, they know exactly where this conversation's going. If your SQL plan gets invalidated for a couple of reasons, so you do some kind of DDL operation on the table, if someone says DBCC drop procedure cache, which they should never do, if they run an update stats on the table, and then your business user goes in and runs, just by coincidence, a query and they search for Kalgoorlie, you can get some very unfortunate query plans generated. And what happens when SQL Server generates a query plan? It caches it and then tries reusing it over and over again. That's when your performance goes haywire. So, in SQL 2016, you are going to be able to spot that in a flash, because you will see a whole pile of dots here, which are the normal execution times, and then you'll see one that is way up here. And when you put your mouse over the plan, you're going to see the query and the stats, and you're going to see that the runtime is way, way, way too high. And this tool is going to let you force plan. The scenario is also very useful if you're upgrading from SQL 2016 to SQL 2018 and you've had a query regression. You're going to be able to spot it immediately and you're going to be able to force plan back to the old plan. This is a really awesome feature, and I highly recommend you give this a go. Native JSON. I will really quickly show you this, but just because I think it's pretty cool. So SQL Server can now output JSON. So if you look at the syntax there, you can see it's very much like, very much like our syntax for handling XML. But who knows the advantage of JSON compared to XML? Efficiency, basically. So JSON is a lot lower overhead at scale. So JSON has a disadvantage that humans are not able to read it, or at least most humans are not able to read it. XML, the majority of humans can read it, but performance on JSON is way ahead of what you can do with XML. Temporal database support. I do have a little demo. We're running a bit behind on time, so I won't show you that. Always encrypted, we've gone through. Row-level security, we talked about. Dynamic data masking, very brief demo coming up. You've got to use this feature. By the way, if anybody wants my demos here, they're just on the standard AdventureWorks database. More than happy to give them to you. Got to be careful. Some of the existing books online and CTP2 documentation out there is a little bit wrong if you use CTP3, which I recommend you do. So these trace flags here enable data masking in CTP 2.2, 2.3, 2.4. They disable it with CTP3, so don't use them. So here I have we'll change back to normal tabular display. Here I have a table which has got a credit card ID. What I will do is copy that and show you the data. Now, I will put a data mask on here. You can see my syntax here. Alter column, credit card ID, add a mask. Now, because this is I think a decimal data type, or an integer, actually, the function will just replace all the numbers with a 0. So I created a user just a little while ago called limited. So I will run SQL Management Studio as limited. Oh, one thing, if you run a couple of copies of SQL Management Studio on CTP3, sometimes it does crash. So, not SQL, just Management Studio. So, I'm DB owner of this database, so I do not see any masking. But if I am the user, the normal user, here is what I see. That column becomes masked. So very useful for customers with sensitive information. Credit card is just one. You can see here I show you who's logged in. So that's me on the other session. What we'll do is put in a text column. I'm adding a column here, and I'm just going to push some data into it. And then I'm adding a more complex function on. So if you look at this, this was meant to be a credit card number. It's, I hope that's not my credit. I don't think that's my credit card number. It could be actually. So you can see my, my function. I've inserted X's into the middle. And I do believe in CTP3, we've actually added another function, and it's called randomized. So you can put in random numbers, I think, but I haven't fully explored that so far. So that is another fantastic function that's coming into our product, dynamic data masking. I have no idea what the SKUs are for SQL 2016. I think some of my Microsoft Australia colleagues, but I haven't heard anything different other than SQL Enterprise Edition is going to have all these features. But then I wouldn't necessarily be the first to know if it was different. Always on. Who's using always on? That's a much better show of hands than in previous years. Please use this feature. Shared disk clustering is we're not going to depreciate it, but please use always on. So we're doing a lot with always on. So we've increased the number of synchronous replicas into 3. And we support automatic failover with priorities to 3. We've got round-robin, load-balanced, read-only connections. And I don't know if we've announced, I think we've announced this. You can actually do it in CTP3, I think. Cascading. Who's heard of cascading? Because I told you the other night. So what you can do, you can have one primary and one secondary. Then off that secondary, you have another secondary, or maybe 2 secondaries. So you have cascade of secondaries. Cascaded secondaries have to be asynchronous, but it means you're no longer limited to the fixed number of always-on nodes, because you can cascade more. A really good feature. Now, there's the next feature on this list. An Australian customer had a large input into this feature. I think it's okay to name. So ING Bank. One of the reasons why we have the distributed transaction coordinator, so you can support 2-phase commit transactions on always-on availability groups. And there is some maybe possibility that we might even backport that for SQL 2014. Still not sure. But this was a big ask. It was the top of the list for always-on when we were developing SQL 2016. And there were quite a number of customers that really demanded that feature, ING Bank in Sydney being one of them. Enhanced online operations I won't go into. 12 terabytes of RAM and 16 sockets. So there is a large HP Superdome Intel server with 16 sockets, and it supports 12 terabytes of RAM, and you can address all of those resources with SQL 2016. So that's quite a bit. Now, any questions on the Tier 1 features before we move on to analytic features? Okay, good. If you've got any questions later, let me know. So deeper insights across data. Now, the number one ask from customers like yourselves was to add Polybase to SQL 2016. So we have done this. Polybase is not a new product. It's been included in PDW, which has more recently been called APS. PDW was Parallel Data Warehouse. So back when I was in SQL Server team, we acquired Data Allegro and created PDW. And Polybase has been in that product for a while. What does this let you do? So in this scenario here, they're talking about an insurance company that has given its customers a device that has a GPS unit in it and probably an accelerometer. And it is sending data to determine whether you are speeding, braking, or accelerating hard in order to determine if you're a risky driver or if you're a safe driver. So that sort of data, the volume of data, it is clearly not suitable for putting into a relational database like any relational database. Your database will inflate and become huge really quickly. If you've got, 2 million cars, all of them sending telemetry information every few seconds, that's a use case for Hadoop. Clear case there. But you want to be able to do a query that joins up your relational data with your Hadoop data. And in SQL 2016, you can do this. It's built in. It's standard part of the product. Any question on this one? Question over here. Longer conversation. Let's talk about that later. Yeah, you can think of it that way, is the short answer. So really good feature built into our standard product. Okay, Microsoft also acquired Revolution Analytics. Now, are there any New Zealanders in the audience? 1, 2, 3. Okay, which country invented R? Auckland University invented R. So the New Zealanders in the audience, I hope, knew that. So we've acquired Revolution Analytics, and we've merged this functionality so you can run R natively inside SQL Server. This is really, really significant and amazing. And another thing here, I should have pointed out before. Remember what we did with in-memory OLTP, even our in-memory OLAP. So, I work a lot with our friends at SAP with a number of features. Has Microsoft told you to throw out all your servers, go and buy an enormously expensive appliance that causes a lot of problems when you try to put it into hosting or cloud? It doesn't work with your monitoring, your backup. When you have to do things like DR, the only answer is go and buy another enormously expensive appliance. This feature here runs on SQL Server. It installs with the SQL Server installer. It immediately works with SQL Management Studio. It works with your backup and restore technology. It works with your existing backup and restore vendor. It has high availability disaster recovery. It runs on Hyper-V. It runs on VMware. It'll run in Azure and it'll run on Amazon. So we're not asking you to throw away your existing investment, come and buy a new appliance from Microsoft at huge cost. This is built in and integrated. What's more? So R is the default language for enterprise forecasting and predictive algorithms. So things like sales forecasting, warehouse efficiency, predictive maintenance. We also have a marketplace here where you can go and look at this already. There are already dozens of R scripts up there. So in this case, a credit risk protection algorithm. So you can download that and you'll need to exercise and train that with your data, but eventually you'll get that algorithm working. So one thing about our integration with R, this opens up all of the interfaces and applications that you had running downstream from SQL Server are able to leverage this. So say you had users using Excel. Well, those users they can now be fed with data from this interface. So another high priority ask from customers was, we want to expose BI and we want to expose it on any platform. So Windows, Android, Apple, whatever, on mobile phone, on tablet. So Microsoft has acquired DataZen. Now, I'm not qualified to necessarily confirm this, so anything I say in this regard, please confirm with your Microsoft salespeople. But from what I know, if you already own SQL Server Enterprise Edition, and if you've got software assurance, then you are already licensed for DataZen Publisher and the back-end components. I think that's correct. Is Mike Ward here? No. Check with your Microsoft sales, but you can download the publisher immediately. It's a free download. Just a couple of things. DataZen is a visualization tool. It's got certain limits around it. It is not a data aggregation tool, so there's a 100,000 row limit with these reports. So, you want to eventually be, if you've got a huge data set, hit SQL Server Analysis Services. Don't use a visualization tool as a data aggregation tool. You're twisting the use case there. But if we had time to do a demo, the dashboards and scorecards you can create with DataZen are amazing. If someone like myself can do it and use it, it must be very simple and easy to use. Okay. So deeper insights, we've given you Polybase. We're enhancing SSIS, so some performance enhancements in SSIS. The performance enhancements in SQL Server Analysis Services as well. SQL Server Data Tools is I think, unless something's changed here, that was also free of charge. Does anybody know? Unless something's changed, that's free of charge, and we've done a major upgrade there. And there is a major upgrade to reporting services as well. So, hyperscale cloud. We've got about 15 minutes left, and I want to show you StretchDB. and hopefully a video too, so we'll speed up a bit. I think some of the other speakers today have covered a little bit of StretchDB. I will show you how this works. Quite a few customers said to us that we've got 20, 30, 40 terabyte systems, but only 10% of that data is current. 90% of the data is archive data. It's very, very infrequently accessed. But it's sitting on my tier 1 storage. I'm having to do backups every night of a 30, 40 terabyte system. That always gets difficult. You eventually have to start using SAN level technology, and that can get expensive. But with SQL Server 2016, you can take that data and archive it to the cloud, and I'm going to show you how to do that right now. Now, first thing, don't worry, there's nothing in SQL Server 2016 that automatically starts sending your data to the cloud. You have to turn this feature on, which is this spconfigure command here. And I think I turned that on just before I did. So I'm going to copy a table, and just for the purpose of the exercise, this is quite a small table. Now there are two ways to do it. Oops. The first is you can go to the table itself and say stretch, or you can go to the database and say tasks, stretch, enable, and I'm creating a master key here. The master key is what's going to hold the component key. We don't have too much time for me to explain the security mechanism that we're utilizing here. But I'm selecting my table. It does a check on that to make sure that there are certain limitations, some data types, for example, and some other requirements need to be met. Now, we're going to do, it's not asking me to do my two-factor authentication because I just did it not so long ago. Now, there's a prize for someone who can tell me what's missing on the list here. Oh, sorry, I don't really have any prizes. Microsoft Australia, they've got prizes. I don't have anything. So, I spoke to the person in charge of this because I knew somebody would notice this, and by the time we RTM, the back-end stretch fabric will include both Australian data centers. Have we said publicly the RTM date for 2016? No, okay. So in my demo, I picked Hong Kong, and we'll use an existing server here. We have to make this is my email address, is Seagarden. Okay, starting IP, some people get a bit confused here. This is the IP address that you are sending from. So in this case, my IP address, you can see up the top, is 40.126.251.170. What happens when we enter this is it actually configures SQL Azure DB to allow connections from this IP address. And with any luck, this demo will work. It's always fun doing live demos here, but if you can the demo, if you do all the steps before, you don't see the dialogues and the wizards, you don't see what you need to see. So it's better to take the risk, I find. So it's contacting the SQL Azure DB in Hong Kong and setting up the schema of this table, and it will replicate over in a few seconds. If we get time, I'll show you backup and restore. When we do a backup of, say I had a 20 terabyte database. If I manage, well, let's make it smaller. Say I had 200 gigabytes. If I pushed 180 gigabytes of that into Azure, and I had 20 gigabytes left on my on-premises system, when I do a backup, it will back up 20 gigabytes. It's what's called a shallow backup. If I lose my system, I'm going to show you the syntax to get it back, because this is another slight gap in our documentation. When I set these up over the weekend, you'll see. So select star from Cameron Stretch. Now, I'm not sure if we had time. Oh, yes, we did. So can you see in my SQL plan that I did a remote query? I'll highlight it here. So it actually went across to Azure, read the contents from SQL Azure DB, then it did a concatenation here. So does someone want to give me a price just to prove I'm not fixing the demo? Make up a number that 29.95. So I'm going to insert that into the table. And we have to be quick here, because it does move the rows off to SQL Azure pretty quickly. There it is. I'm not sure whether, oh, looks like it already replicated it off to SQL Azure DB. If we look in the monitor, we can see the rows getting synced up in Azure. And here it's showing they're all synced up. I've got no local rows. So very, very quickly, I'm going to show you a couple of limits around this. Obviously, we can't do an update operation. They are archives. When it goes to SQL Azure DB, it is read-only. So I cannot do an update or a delete. I don't think we've got time to do the backup restore, because I do want to show you SQL Data Warehouse as well. But just to say, if you do this yourself, the key to getting it working is to look into database scoped credentials. That is the authentication mechanism. And there's a stored procedure you run here, which is SP Remote Data Access Reauthorize DB. So if I destroyed my on-premise database, which was 20 gig, I've got 180 gig in Azure. To bring that data back is very quick. It takes about 2 minutes to reattach the database. I want to leave some time for questions, but we need to jump forward, because stretch tables in Azure, Power BI. So some of you don't want to put your data into Azure, but you want to use Power BI. We now support running Power BI in Azure and keeping your data on-premise. That's now supported. On-premises, sorry, excuse me. There's one thing I want to show you. It's called SQL Data Warehouse, and it is our MPP solution in the cloud. Who here is using Teradata, Greenplum, Vertica, Oracle Exadata? Who's using an MPP data warehouse? Just a few of you. has the cost of it exceeded your imagination? Typically it does. The reason is, now there's been an architectural change and we think we've fixed it with this solution. We've disconnected storage and compute. So you can have a massive warehouse that you only use at month end, or you only use it at Christmas time because you're doing shopping trolley analysis to generate recommended things saying, you know, the last people who bought this, they also liked to buy this. So what it's possible to do with SQL Data Warehouse is reduce down your compute, which is the expensive part, and keep your storage the same. We've disconnected those two elements to a large degree. Now, I've got very little time left, but I will show you. If you want to use this, go to portal.azure.com and click on New and go to Data and Storage and click on SQL Data Warehouse, which is in preview still. And you decide how many data warehouse unit components you want. And to ramp up or ramp down capacity is very simple for you to do. I would create it, but the internal account that I have doesn't have the permission to create a SQL data warehouse. So I can't demo this to you. But this is really powerful and really useful. If you're finding that your current Teradata, Greenplum, Vertica is not working out from a cost perspective, then please use this. Okay, I think we need to wrap up. So, has anyone got any questions? I know it was a lot of content to cover. Actually, if you've got a question, do you mind coming up to, at either side of the stage, there's a microphone. It's just so that everyone else can hear and that it's recorded on camera. Maybe you go first.
Hi, good afternoon. The polybase feature that you've discussed, at the end of the day, does it fire a HiveQL query on your HBase cluster?
Yeah, so yeah, we can go into more details, but yes, that it's triggering that on your Hadoop cluster, yes.
So is the HiveQL then converted into MapReduce, or is it directly HiveQL on the files?
I think that depends. I'm not the expert on Polybase, but we do have a session tomorrow with someone up. Come and see me after. I'll tell you which session to go to cover that.
Thank you.
Question over here.
All these new amazing features, they seem to be targeting the enterprise version of SQL Server. So is there anything new in standard? For example, the table stretching, this is extremely useful, and it seems to be targeting enterprise as well.
Is there anybody from sales or marketing here?
No? That's fine. Yeah.
I'm sorry, I really don't know.
It's an impressive addition, but it seems that it's only enterprise. And I think many people here, they use the standard version of SQL Server.
Yeah, I know we have been pushing more on things like backup compression got pushed into standard, clustering into standard.
No, that's fine. Right,
yeah, I'm really sorry. I just don't know. Question over here.
Compression, on the encryption that you spoke about.
Yeah.
How does that give you more overhead with a DBA query, fixing records, update where value is equal to X?
Okay, so the overhead, remember that the encryption and decryption is happening where? On the client side. So typically you're able to scale out your client side horizontally. So if you're doing, remember I showed you we have deterministic and randomized. The randomized is a bit more expensive. If it was a really hot table and you were, pounding that table with insert, update, delete, I can imagine that eventually your client, that could push client CPU, but you can scale out your client layer typically. On the SQL Server side, instead of storing, a relatively small column, you're getting a big key, so that's a little bit of overhead, I guess. But I wouldn't expect, on modern fast hardware, I don't think it'd be a big issue. Question?
Yes, in regards to the always encrypted technology,
Yep.
is there like a key exchange between the server and the client, or do you need to set up some certificate services?
There are a couple of ways of doing it. You can store the key on SQL Server, but the key, we recommend key management, and the keys reside on the client. So there's MSDN blog that come and see me later. There's an MSDN blog that covers this quite clearly. Obviously, you do have to be quite careful with your keys, things like expiration dates, things like that. You do have to be quite careful, but we are documenting this. Another question.
Yes, I have a question against stretching database tables.
Yeah.
Does it currently work on the entire table, or can you actually sort of have partitions or clauses to decide what parts gets? Usually what happens is you have huge
Yep.
tables and you have a massive amount of old data, but you also have a massive amount of new data that you still want to query quite often. Does that work yet? Or?
So today, it is all or nothing.
Okay.
But I mean, I don't know for sure, but it is definitely being thought about to look at other options there. So, yeah, very good question. StretchDB is an all or nothing thing today. You can't pick a partition off a table, but you are not the first person who's asked that question. So I would say for SQL 2016, I mean, I've been working in and around SQL Server for quite a while, and the amount of features we're shipping in 2016 staggers me. So I think we've just had our fill for 2016. Wait for 2018.
Great, thanks.
One more question?
In dynamic masking, can we limit the number of users, like who can see and who can't see the data?
Yeah, dynamic data masking. So I had to cut the demo a bit. You can grant unmask. Well, why don't I do it? Are we going to get kicked out of this room soon, or doesn't look like it? Because we're over time. If I grant unmask to that user, you can see it was masked here, and I've just unmasked. So yeah, obviously dynamic data masking you have to use in conjunction with things like auditing, otherwise someone will grant unmask. Okay, please download SQL 2016 CTP3. Let us know what you think of it. Connect.microsoft.com or the Yammer group, or email any one of us. We'd love you to use the product, love you to try it. Please send us your feedback, and thanks for your time. Thanks a lot.
alive.